Hey, I have a probability problem for you to look at. This is in Unit 4, from Unit 4 test. So grab your Unit 4 test. This is number 2. It's a probability problem. Let's review. Here we go. If you randomly select one student, what's the probability that he or she is a senior or walks to school? Show your work. Okay. So we have a two-way table, summarizes seniors and juniors at high school, how they get to school, okay? All right, so or. Well, anytime we have a probability or, we know that we add. Now, we got to be a little careful. The probability of A or B is the probability that A happens plus the probability that B happens, and then minus the probability that both happen, right? A and B. And I'm running out of room. So I'm just going to write both. Probability of both. Okay? In other words, A and B. Okay? Because there could be some overlap that we have to subtract. Now, if these are disjoint probabilities, we don't have any overlap, we're subtracting 0. Okay? So here we go. So senior or walks. Now I'm going to show you two quick approaches here for this. Both will get you the right answer, and they're just kind of slightly different. But let's take a look here. A in this case is senior, B is walk. So we want the probability that randomly selected student is a senior or walks. So that's probability that randomly selected student is a senior. And so I look here and I see that there are 250 out of 550, 250 out of 550. There's your probability that randomly selected student is a senior. And we're going to add. Let me get rid of that. That's bothering me. Okay. And of course, that's an or, so it's plus. All right, probability that the person walks to school. Well, that's the 88 out of 550. Okay, so that's 88 out of 550. So we've got 88 out of 550. But we have to subtract the overlap, right? There are 40 students that are senior and walk. So I'm counting those 40 seniors here and here. I don't want to do that. I only want to count it once, not twice. So I have to subtract the probability that randomly selected student is a senior and they walk to school. Okay, and so that's how we're going to get the 298 out of 550, which is approximately 0.5418. And I did say that I would show you another approach. So let's take a look at this table. We want, remember, the probability that randomly selected student is a senior or walks. Okay, so here are the seniors. Here are the students that walk. Okay, so it's easy enough to go to all these numbers and just add up the ones that we want. We just got to be careful. We don't want to say the 40 twice, right? And so to get our 298 students, it's the 48 plus 40 plus 64 plus 146, and we put that out of the total number of students, 550. And of course, make sure that you've shown your work. Let's take a look at B. If you randomly select one student, what is the probability that he or she is a senior given that he or she walks to school? Okay, given that he or she walks to school. So we're just looking at this part, this given, right? We're just looking at the ones that walk to school. The total then, for the denominator, of course, is 88. So we're just looking at the 88 students that walk to school, and we see that 40 of them are seniors. And that's approximately 0.4545. And there we go. All right, independent events. Let's review how to do this, and then we'll dig into the problem a little bit. If A and B are independent events, then, and this is from page 369 in your book, if you want to take a look at that, then the probability of B given A equals the probability of B. And what that's saying is, it doesn't matter if A happens or not, the probability that B happens is going to be the same, whether A happens or not. So that's the test for independence. But I want you to notice something that on the previous page, page 368, it reminds us that this right here, the probability of B given A, reminds us what that is. It's the probability of A and B divided by the probability of A. So if we substitute that in, and then because this is an equation, I can multiply the probability of A on both sides. I can see that this is another thing that I know has to be true if A and B are independent events. I know that the probability of A and B equals the probability of B times the probability of A. And you could, of course, write the probability of A times the probability of B. And we've seen this before. We've used it when we find things like find the probability that we roll 2 2s in a row. We roll the dice twice, and what's the probability that we get 2 2s? Well, the probability that we get a 2 on the first and a 2 on the second would be the probability, multiply the two probabilities. Probability of a 2 on the first, 1/2, 1/6, and times the probability on the second is also the same, 1/6 times 1/6. Well, the only time that works is when the events are independent, and of course rolling dice, they're independent events. So we can do part C one of two ways. We could either check to see if these two things are equal or these two things are equal. Let's go back to part C and let's see what that means in the context of this problem. Are being a senior and walking to school independent events? Show your work to justify your reasoning. Okay, so you can do you can either do this blue part, okay, or the red part, okay? So the blue part, that's what I showed you from page, what was that, 369, okay? And this was the other way. So either one is fine. Let me show you what that looks like. Okay, so put a question mark right there above the equal signs, okay? Because you don't want to start with the idea that these are equal. You're checking to see if they're equal, and if they are equal, then the events are independent. So make sure you're very clear to the reader what you're checking for, and be clear in your explanation. And it says show your work to justify your reasoning. So make sure you're showing enough work. So this is what we're checking to see if this equals this. Well, the probability that a randomly selected student is a senior, giving that they walk to school, right? They walk, there's 88 people that walk, 40 of them are seniors, right? And so that was 40 out of 88. We're checking to see if that equals, so put a question mark over the equal sign, checking to see if that equals the probability of that randomly selected student being a senior, which is 250 seniors out of 550. People, right? Students. So 250 out of 550. Well, when you plug that in your calculator, you get 0.4545 on one side, you get 0.4545 on the other. So those two are equal. And because these are equal, these two events, being a senior and walking to school, are independent. The red part, you could do that as well. That's very similar. You're checking to see if this thing equals that thing. So you have a question mark above the equal sign. You're checking to see if they're equal. If they are, that means these two events, senior and walks, they're independent. And of course, if they're not equal, they're not independent events. So here we go. Probability of senior and walks. Okay, probability of senior and walks. Well, that's 40. That's 40 out of a total of 550. So that's 40 out of 550. I'm checking to see if that equals probability of senior times the probability of walks, right? Probability of senior. Well, I see that there are 250 seniors out of a total of 550 students. So the probability that my randomly selected student is a senior is 250 out of 550. Okay, so times, because that's what this means, probability that they walk. Well, a total of 88 out of 550 students walk, right? So you're trying to figure out if this thing equals this. So you grab your calculator and you realize that that is, whoops, what do we get there? We get 0.0727 on one side. We get 0.07 0, 7 to 7 on the other side. And because they're equal, these events are independent. All right, keep working hard, keep studying. Let me know if you have any questions.